Hey friends, welcome to the channel. Today in this video we're going to solve the first problem of week 3 of CS50, which is sort. So if you come here, this is the problem that we're going to solve, sort. And the very first thing that we have to do, I'll explain the problem in a moment, but the very first thing that we have to do is we have to go to cs50.dev, this particular website, cs50.dev, and once you click on login, you will come to this page. And we created the other folders previously in the previous videos, so today we are going to do this. We'll first create the week 3 folder, so we'll say mkdir week 3, press enter, and once you're here we'll navigate to that folder, week 3, press enter, and then come down, click here, download distribution files in the distribution code, expand this, and then copy this entire line. Come back here and you just paste it and press enter, and then what you'll see is we downloaded a .zip file, sort.zip. So to extract that, we'll say unzip sort.zip. So we'll come here, we'll say unzip sort.zip, press enter, and we got a folder. And then what we are supposed to do is we will remove the sort.zip file, rm sort.zip, press enter, and it will ask us, do you want to confirm? Y for yes, and press enter. So that is gone. Okay, so I'll clear the screen, and then we'll go to cd sort ls. Okay, so these are all the files that we have. These are the files that we are given. So what we're supposed to do is we have 3 compiled files, sort1, sort2, sort3, as in like the CS50 staff, they wrote 3 programs. They compiled it as in make sort1, make sort2, make sort3, and all of these 3 programs, they consist of different sorting algorithms. So what we are supposed to do is we are supposed to identify which sorting algorithm each of these programs use, and then we are supposed to record the answer in answers.txt file, right? So sort1 uses this algorithm, and how do we know that? We have to give the reason. Similarly sort2 and sort3, right? So to find that out, let me first clear the screen here, clear the terminal, and I'll say, okay, so we have 3 programs, and then we have the list that we can use to run some tests. So the way that we are going to find out is by executing these programs on our given lists, and also we are going to find that out by using this particular chart. If you remember from the lecture, there are 3 sorting algorithms that we are using: selection sort, bubble sort, and merge sort. Selection sort, the best time complexity is n square, and so is the worst, as in it takes more time and the same time in the best case and the worst case. Similarly bubble sort, in the best case scenario, as in if the list was already sorted, bubble sort would take omega of n, and similarly in the worst case, if it is unsorted, bubble sort would take big O of n square, right? But merge sort on the other hand would take the same time for the best case and the worst case. Okay, cool. So what are we going to do with that? So the way to execute these programs on these particular files is by doing this. So we'll say sort1, and then where do we want to execute this file, as in on which file? On the sorted files, random files, or reversed file? A nice way I think to solve it would be to take maybe a random list of maybe 10,000, because 5,000 would be too small and 50,000 might take some time, some significant time. So 10,000 would be a cool place to be. Okay, so first we'll run it on random list and then on sorted list, and then I'll say random 10,000.txt, press enter. So our sort1 program did sort the random 10,000 text, but we were not really able to calculate the time. So in order to calculate the time, here's what we do. We first say time, and then we execute the program. So ./sort1, and then we say random 10,000 text, and then we run it, and then we have the time. We get 3 times: the system time, user time, and real time. This is what matters the most, right? Okay. So let's take notes, and our notes are going to be sort1 random 10k, how much time that takes, and then sort1, and we will also run it on sorted text so that we are able to find the best case timings. So sort1 sorted 10k, right? And then we are going to do the same for everything. We'll come here, let's just change this to 2 to, and similarly sort 3. So sort 1 on random 10k, it took point as in 0 minutes and 0.221 seconds. So I'll say 0.221 seconds. Okay, cool. And then if I were to do this for sort 2, how much time would that take? So let's come back here, sort 2, press enter. Okay, so sort 2 took 0.106 seconds. Once we calculate for all of the sorting algorithms that we are given, we will be able to compare and contrast. And after comparing, we'll be able to figure out which algorithm each of these use. And then I'll say sort 3, press enter, 0.139. Let me do this. Alright, so sort 3 takes 0.139 seconds. Okay, fine. But what if we were to say sort 1 and then if we were to run it on sorted 10,000? If you press enter, okay, that is a major difference, right? So sort 1 took 0.221 seconds on random letters, as in random words, but on the sorted list it took only 0.060 seconds. That's very less, right? So this is definitely not selection sort, because that takes n square in both the cases. And then execute the program for sort 2, press enter. That's good also. Let's see, 0.0774 seconds. All right, interesting. And now if we were to run it on sort 3, there we go. I think we have our answer, 0.134 seconds. So this sort 3 program took about the same time for the sorted list and the random list, right? So definitely this is our selection sort. Why? Because it takes about the same and more time for sorted and random lists. Okay, this is done. We have the sort 3 answer. And if you look here, we don't really have a very good comparison here. So you know what? Let's run it again. Okay. Alright, this is sorted. So I'll just update the answers, and then similarly it takes random for random 10,000. Oh, wow. You see that? For sort 2, random 10,000, it now takes just 50 seconds and now 67 seconds. So I can update this, 0.067. Sometimes this happens, we are not able to get the accurate runtime. So in that case, we run the program a few more times, and then this is the conclusion that we came to. Like, this was the apparent timing, right? So as you can see here, sort 2 took about the same time for the random list and the sorted list. It took the same time and it took very less time as compared to sort 3. So sort 3 is selection sort, and sort 2 is our fastest sorting algorithm, which definitely is merge sort. And how do we know that? We know that because it takes about the same and less time for sorted and random lists. So selection sort is taken, merge sort is taken, what is remaining? That is bubble sort. Bubble sort, how do we know that? Because as we can see, it takes less time for sorted list and more time for random list. Okay, and now we can remove the notes that we took. And now what we're going to do is, let me cancel this. Okay, now what we are going to do is, we'll come here, we will try to check the correctness of our program, whether or not our answers are right. So I'll paste the command that I copied, and then we'll wait for a moment. Alright, there we go. All the answers are correct and there's no real styling needed. So we'll just copy the submit code. We'll come here, we'll press it, we'll put it there, and we'll press enter. And alright, are you sure you want to submit? Yes, I am. Press enter. Alright, we can go to this link, command click or control click, to see our score, and give it a moment. As you can see, waiting on results. Alright, there we go. Check 50 gave us 3/3, which is great. So we basically got the full points. So this is how to solve the sorted problem of week 3. Similarly, you can see a playlist on the screen somewhere. Click on that playlist to watch all the other videos for all the upcoming problem sets. I'll see you in the next videos. See you there. Bye.